What was the problem? Anyone just give me? Acha, I remember that thing now. Was I think X was given as a function of time, and
हाँ
probably we are trying to get out everything out of the horoscope of that particular equation. Chalo, theek hai. Okay, chalo. Let's not waste any time. Let's start. So, how was your Saraswati Puja? Like you guys made me reschedule the session because of Saraswati Puja. Although, did you
very
guys
event.
very eventful? What about others, especially class 11 people? Like, what was the thing with you guys? Like, did you guys go out in Saraswati Puja? अच्छा मतलब what do you go in सरस्वती पूजा मतलब पेंडल हॉपिंग मतलब वन लाइक स्कूल में तो नहीं स्कूल में तो होता है आई गेस ना
फिर
आई डोंट
स्कूल
नो
को जाता नहीं।
मेरा स्कूल में तो नहीं होता था आई डोंट नो लाइक आप लोगों का स्कूल में होता है और यू गाइस लाइक गो फ्रॉम वन कॉम्प्लेक्स टू अनदर कॉम्प्लेक्स अच्छा आई थिंक क्लब्स में भी होता है सरस्वती पूजा इफ आई एम नॉट रॉन्ग चलो गुड सो व्हाट डिड यू प्रे मतलब थोड़ा असाइनमेंट टाइम में हो जाए सबमिट डू यू गाइस प्रे दिस थिंग्स और मतलब celebrated this as a Bengali, what do you call this, Bengali Valentine's Day, or you guys celebrated this as a Bengali Valentine's Day? In fact, like I was checking the statuses of few of my ex students, almost everyone was celebrating it like a Valentine's Day, man. It's Saraswati Puja. You are supposed to pray to the goddess कि थोड़ा सा सुबुद्धि दो कि assignment time में हो जाए. I don't know. You guys made me reschedule the session. Or chalo. Let's come to the next topic. Simple harmonic motion as projection of uniform circular motion. Listen to me very carefully. This particular concept is something that you are learning for the first time, and a class of numericals can be solved using this particular concepts. Okay? मतलब if you can understand this particular concept properly, there will be few problems जो थोड़ा सा easily थोड़ा सा कम time में solve हो जाएगा. ठीक है? चलो, let's try to understand what I am saying. Suppose Suppose there is a particle which is performing uniform circular motion in a straight sorry in a circle whose radius is nothing but capital A. ठीक है? Let's say the particle is performing uniform circular motion in the clockwise sense with an angular speed of omega. ठीक? No big deal. बेटा मान ले कि there is a white screen here. ठीक है? चलो मान लो कि there is a white screen here. This is a white screen. ठीक है?
तो सर तो रेड से बनाया आपने।
अरे अच्छा चलो 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 लेट्स बी एग्जैक्ट जस्ट टू सेटिस्फाई यू कहाँ व्हाइट कलर मिलेगा सर चलो ये व्हाइट कलर ठीक है ना हैप्पी चलो चलो लेट्स से वी हैव अ व्हाइट स्क्रीन हियर ठीक है नाउ लिसन टू मी वेरी केयरफुली but when your particle let's say at a particular instant the particle which is performing uniform circular motion is present at this point what I'm saying the particle which is performing uniform circular motion let's say that particle is present at this point ठीक है but when the UCM वाला particle is at this point can you say इसका projection screen में कहाँ आएगा but like in a very lame language you can say you can think in this way कि projection is nothing but its shadow ठीक है तो इसका shadow कहाँ आएगा can I say its projection or shadow white screen में will be formed at this particular point ठीक है it's moving in the clockwise sense so maybe after some time your particle will reach at this particular position when the UCM वाला particle is reach at this position इसका projection कहाँ form होगा can I say इसका projection will be formed somewhere here yes or no make sense now listen to me very carefully what I am saying when the UCM वाला particle is moving from here to here from point A to point B can I say guys is its projection is traveling from this point to this point can I say this yes or no when the UCM wala particle is traveling from point A to point B will it be justified to say that its projection will be traveling from this point to this point yes or no yes no big deal Babu, after some time, this particular point, sorry, this particular particle will reach at this particular point, let's say point C. ठीक है. When the UCM वाला particle is at point C, इसका projection कहाँ form होगा? Where will its projection be formed? Can I say its projection will again be formed at this particular point? Yes or no? Clear? So when the UCM wala particle travels from point B to point C, can I say its projection travels from rightmost extreme position to this position? Can I say projection will be traveling from this point to this point? Yes or no? No big deal. UCM wala particle after some time will reach this particular point, point D. But when the UCM reaches at this particular position, its projection kaha form hoga? Can I say its projection will be formed at this particular point? Yes or no? Clear? So, Babu, can I make a comment? When the UCM wala particle travels from point C to point D, the SHM wala particle travels from this point to this point? Yes or no? Make sense? Finally, when the UCM wala particle travels from point D to point A, will it be justified to say that its projection will again travel from the leftmost extreme position to the mean position? Yes or no? Clear? So based on this particular observation, can I make a comment, guys? When the UCM wala particle makes a full cycle, it completes a full cycle, how its projection is moving? Can I say its projection is moving like this? From this point, it is first traveling to the rightmost extreme position. Then from rightmost extreme position, it is coming back to the main position. From the main position, it is going to the left extreme position. Then from the left extreme position, it's again coming back to the main position. Clear? So will it be justified, guys, if I make a comment कि when the UCM wala particle performs a complete cycle, its projection performs a complete oscillation? Sir, why you are saying that the projection is performing oscillation? Babu, isn't the projection making a to and fro motion about this particular point? Can I say its projection is making a to and fro motion about this point? So definitely the projection is performing an oscillation. Yes or no? Clear? Tell me. If I make this statement, when the UCM wala particle finishes a complete cycle, its projection will perform a complete oscillation. ज- जहां से स्टार्ट किया था इट ऑलरेडी इट अगेन कम बैक टू द सेम पोजीशन ना. यस और नो? बोल भाई. इज इट क्लियर नाउ? Babu, have I got any proof that this oscillation is an SHM? You will be telling me no, sir. All I know is when the UCM wala particle is making a complete circle, its projection will be performing a complete oscillation. But I am not sure till now whether this oscillation is an SHM or not, right? SHM was a special case of oscillation. All I know is this projection is performing an oscillation. But whether this oscillation is simple harmonic motion or not, वो मुझे देखना पड़ेगा. We have to check if it is an SHM or not. SHM is a special case of periodic oscillation we had seen in the last class. Does it make sense till now? So now let us try to see if we can prove that this projection is basically performing an SHM. Is it clear? First, I proved when a particle performs a uniform circular motion, its projection performs an oscillation. Now, I am trying to prove if this oscillation can be proved to be an SHM or not. I am not sure till now whether this oscillation is SHM. So, let's try to prove if this oscillation is an SHM or not. Am I making sense till now? Or sub everything is becoming tangent to your brain? कुछ जा रहा है दिमाग के अंदर अंदर तक? Anyone? Am I audible? Is the voice coming properly? Anyone confirm me once? Hello, am I audible, guys?
Yes, sir.
Listen to me. Babu, मान ले at t equal to 0, UCM वाला particle was present at point A. Sir, why are you assuming कि at t equal to 0, UCM वाला particle is present at point A? It could have been present at point B. अरे भाई, I know it could have been present at point B, but let's assume ना, we have to prove something. So let's assume कि at t equal to 0, your UCM वाला particle is present at point A. ठीक है? This is my assumption. तो दोस्त, when the particle is present at t equal to 0 at point A, इसका projection कहाँ form होगा? At this particular point. No big deal. But in t time, how much angle will this travel? In t time, how much angle will the radius vector travel? Can I say that the radius vector will traverse an angle of If omega is the angular speed, so in per second, it is traveling an angle of omega radian. So in t time, how much angle it will travel? Omega t radian. So can I say at t time, your particle will be present somewhere here, and the radius vector will traverse an angle of omega t radian? Yes or no? Make sense? When your particle is present here, इसका projection कहाँ form होगा? Can I say its projection will be performed? Oh, sorry, its projection will be formed somewhere here? Yes or no? Good, sir. Makes sense. So tell me, does it make sense if I say when the particle travels from point A to this point, चलो इसको नाम दे देते हैं point P. When the particle travels from point A to point P, its projection travels from this point to this point. Yes or no? Is it clear? Making sense? Is it clear, guys? Are you being able to follow? Yes or no? यूसीएम वाला पार्टिकल ट्रेवल कर रहा है फ्रॉम पॉइंट ए टू पॉइंट पी. इसका प्रोजेक्शन कहां ट्रेवल कर रहा है? द प्रोजेक्शन इज ट्रेवलिंग फ्रॉम, its projection is traveling from this point to this point. Make sense? But can I calculate the length of this? Can I calculate this much length? आप बोलोगे सर it's a basic geometry, calculate कर लो. कैसे करूं? This particular length is nothing but our a. Guys, this is a. I told you that the radius is a. How much was this much angle? Omega t. Someone has microphone on, switch off the microphone. Someone got microphone on, please check and switch off. How much is this length? Is this a sine omega t? This much length is a sine omega t. Hopefully, I don't need to explain how I got this. Sine omega t equal to height by hypotenuse. So this much length will come out to be a sine omega t. So ये वाला length कितना होगा? Can I say this is nothing but a sine omega t? Yes or no? Make sense? Now listen to me very carefully. Bo, if I ask you what is the displacement of the projection after t time, आपका आंसर क्या होगा? आप बोलोगे simple. It started its motion from this particular position. T time में how much distance it has traveled? Sir, in t time it has traveled a distance of a sine omega t. Uh, does it resemble the equation that we got regarding the variation of displacement with respect to time for SHM? Guys, what was the standard equation for the variation of x with respect to t?
Sine
What was-
omega.
it was x equal to a sine omega t plus phi, something we got, or phi is called as a h constant or the initial phase.
तो सर 5 मतलब तो कुछ नहीं तो लिखने का ज़रूरी है?
नहीं कुछ नहीं. In this case I don't have phi, but I will have some non-zero value of phi. We'll see this. But anyway, but can I say, guys, this particular equation that we have got, x equal to a sine omega t, this is just a special case of this general equation that we got under the condition phi equal to 0. Isn't it, guys? This is just a special case of this under the condition phi equal to 0. So when it has been proved that this is the equation of an SHM, so can I make a comment, guys? This projection is performing an SHM. That the projection was performing an oscillation, that we had already proved, na? And we have also been
সার্কেলের
able to
সেন্টারটা সরিয়ে দিলে তো ব্যাপারটা ফাইটা চলে আসবে না?
circle center na সরালে নয়, initial position change. We'll see this after some time. So the projection of UCM is an SHM. We have been able to prove this. Clear? Guys, we had already proved that this particular projection is an oscillation, right? Didn't we prove first it moving from here to there, then it's going from here to there, then it is again coming back to this midpoint position. We had already proved, right, that the projection is performing an oscillation. And we have also been able to prove that this oscillation performed by the projection is a special case of oscillation that we had studied in the last class, which is termed as simple harmonic motion or SHM. Does it make sense? There is nothing that you cannot understand. Yes or no? So we have got a very powerful result. What we have got? We have got if a particle if a particle performs performs uniform circular motion in a circle of radius a. But what was the radius of the circle, guys? What is the radius of the circle? Was it a? Did we assume the radius to be a? How much is this much length then? Is it a, guys? From the picture, can I say, guys, if this is a, this much length is also supposed to be a only? Yes or no? Can I say this much length is supposed to be a only? This is the main position. This is the right extreme position, what's the separation between the mean position and one of the extreme positions? What do you call it? We call it amplitude. So can we make this comment, guys? Whatever is the radius of UCM, same is the amplitude of the SHM. Yes. So if a particle performs uniform circular motion in a circle of radius A, its projection, its projection will perform, its projection will perform an SHM with amplitude. What is amplitude, guys? Same as the radius of the UCM, right? So will the amplitude be equal to A only? Yes or no? Clear? Now listen to me very carefully. Now, what is this omega? Can I say this omega was nothing but the angular speed of UCM? And in this equation, can I say, guys, this omega is something we had studied in the last class called as the angular frequency of the SHM. So can I say, ladies and gentlemen, whatever is the angular speed of UCM, same is the angular frequency of the corresponding SHM molar particle. Yes or no? Clear? Makes sense? And angular speed of UCM is same as angular frequency of SHM. Yes or no? Any doubt? Is it clear, guys? Have you been able to understand? Yes or no? ठीक है दोस्त. Have you been able to understand till now? Anything that you couldn't follow? Please let me know. We'll discuss that part. And if you have understood everything, then we can proceed. ठीक है दोस्त. Everyone has been able to copy up to this. Can we proceed? Am I audible, guys? Is a voice coming? Please confirm me, anyone.
Yes, sir.
ठीक है. Have you been able to copy up to this? चलो. Listen to me. Now, if someone asks in this case, what is the time period of the UCM? What will be the time period of UCM? So it will be simple. If the UCM wala particle is moving at an angular speed omega, the time period is supposed to be 2 pi by
Pi by
omega. And if someone asks what is the time period of SHM, we will say it's a very lame question. Whatever is the time period of UCM, same is the time period of SHM, because we just saw na sir, the time taken for the UCM to complete one full circle is same as the time taken by the SHM molar particle to perform a complete oscillation. So iska bhi time period 2 pi by omega hi hoga. What's the big deal? Isn't it? A very lame question. Now the question is, sir, why did you learn something like this? मतलब ऐसे ही क्या, मतलब कोई एक दिन कोई एक साइंटिस्ट उसका नींद नहीं आ रहा था and suddenly at 3:17 a.m. at night he or she woke up and decided कि ऐसा कोई theory दे देगा कि SHM is a projection of UCM. Obviously there is supposed to be some utility of this particular concept, otherwise what's the meaning of learning something like this? ठीक है? तो there has to be some benefit of learning this concept. So let us try to understand कि इसका benefit कहाँ आएगा. But first tell me, have you been able to understand this concept? Have you been able to grasp this fact कि if a particle is performing an UCM, its projection will perform a linear SHM. ठीक है? Whatever is the radius of UCM, same is the amplitude of SHM. Whatever is the angular frequency of SHM, same is the angular speed of UCM. ठीक है? But the question still persists कि why are we learning this? मतलब there has to be a reason. So let us try to understand. Let's take a cakewalk problem first, and gradually we'll increase the difficulty level. Okay, let's start with the cakewalk problem first. Suppose I have a situation. Okay, chalo, let's start with this. Let's start with the most basic one. Suppose there is a particle which is performing linear simple harmonic motion. ठीक है? Suppose the mean position is x equal to 0, the rightmost extreme position is x equal to plus a, the leftmost extreme position is x equal to minus a. मान ले कि at t equal to 0, the position and velocity of the particle is as given. What did I say, guys? At t equal to 0, the position and velocity of the particle is as given. So what do you mean by is as given? मतलब I mean at t equal to 0, the particle is present at x equal to 0 and its velocity is omega a towards right. ठीक है, nothing that you cannot understand. My question is simple. um, write the write down the equation of variation of displacement with respect to time for the particle. ठीक है. Now there are two approaches by which we can attempt to solve this problem. Listen to me very carefully. Number one is a pure analytical approach. What is the analytical approach? Pure and simple. Listen. Is this particle performing SHM? Sir, you only told us it is performing SHM. Very good. Is it performing linear SHM? Sir, you have drawn na sir. It is moving from x equal to minus a to plus a along a straight line. So definitely it's a linear SHM. What is the mean position? Sir, you have drawn the picture, no? Left extreme position is x equal to minus a, right extreme is x equal to plus a. So what is the mean position? X equal to 0. Babu, do I already know if there is a particle performing linear SHM with the mean position at x equal to 0, what is the form of the variation of displacement with respect to time? Do you already know this? Did you already derive this in the last class? Was the variation of displacement with respect to time something like this? X equal to some a sine
Sin
omega t
omega
plus
t.
phi. Plus, this is something that you already know from the last class. Clear? Now listen to me very
Phi to
carefully.
0.
The thing is, Babu, what was A? A was the amplitude. Here also, what is the amplitude? Plus A. So A to already given in the question. What is omega? Sir, omega was angular frequency. Has the omega been given in the question? Sir. How did you know the omega is given in the question? Sir, you have already told us na at t equal to 0 velocity is omega a. और सर मीन पोजीशन में वेलोसिटी क्या होता है सर? एंगुलर फ्रीक्वेंसी टाइम्स एम्पलीट्यूड. सो सर ओमेगा इज आल्सो गिवन इन द प्रॉब्लम, सो नो प्रॉब्लम विद ओमेगा. बट द थिंग इज आई डू नॉट डायरेक्टली नो द वैल्यू ऑफ phi. So I have to do something to get the value of phi. That's the first job. I have to do something to get the value of phi. कैसे करेंगे? Let's make use of the informations given in the problem. There is an information given that at t equal to 0, the displacement is 0 from the mean position. Isn't it given, guys, at t equal to 0, x equal to 0? It's given in the problem. So let's make use of this information and let's see what we are getting. If I substitute t by 0, the problem is saying the particle is present at x equal to 0 only. So x equal to 0 and t equal to 0 are supposed to satisfy the equation. So x equal to 0 equal to a sine 0 plus phi. Is sine phi coming out to be equal to 0? If sine phi equal to 0, what is phi? अब बोलोगे सर फाई का दो
0.
पॉसिबल वैल्यू है. नहीं, दो पॉसिबल वैल्यू विद इन 0 to 2 pi radian. If I take one complete angular space from 0 to 2 pi radian, there can be two different values of phi which will make sine equal to 0. What are the two values of pi? One is 0 radian and the other possible value is pi radian, मतलब 180 degree. Now for a particular SHM, I cannot have two different values of phi. एक ही वैल्यू ऑफ phi होगा ना दोस्त. For a particular linear SHM, can you have two different values of phi? The answer is no. We cannot have two different values of phi. We can have only a single value of phi. So the question is, which value of phi I am supposed to take, 0 or phi? For that, let us make use of another information given, that is at t equal to 0, velocity is a omega towards right. Have we made use of this information? Yes, no, sir. So let's see if I can get something by making use of this information. Chalo. Now, when I differentiate displacement with respect to time, what do we get? Velocity. X को differentiate करोगे तो with respect to time क्या आएगा? Velocity. A into sin का derivative क्या आता है दोस्त? Cos आता है. Can we make use of the chain rule of differentiation? इसको chain rule से differentiate करोगे तो omega t का derivative होगा omega. Phi is a constant, derivative आएगा 0. So it will be omega a cos omega t plus phi. Now put t equal to 0. Now if I put t equal to 0, क्या आएगा? V equal to omega a cos phi. Are you getting this? Anyone? Are we getting v equal to omega a cos phi? Yes. Now listen to me very carefully. I have got, there can be two different possible values of phi. One is 0 and the other one is pi radian. If I put phi equal to 0, sorry, yeah, if I put phi equal to 0, then velocity क्या आएगा? आप बोलोगे simple sir, omega a into cos 0 is 1, it will be plus omega a. If I substitute phi equal to pi radian or 180 degree, velocity क्या आएगा? omega a cos pi is minus 1, it will be coming out to be minus omega a. Now, which one is acceptable? Your answer will be, sir, it was given in the problem कि at t equal to 0, the velocity is given towards right, sir. Okay. By default, the convention that we used in the last class while deriving was towards right is positive, towards left is negative. That was the convention we had made use of while deriving, right? So, this particular one is not acceptable for us because this one is saying if you put phi equal to pi, velocity will come out to be negative. Can velocity be negative? No, sir. So the only acceptable value is phi equal to 0. So bas, we got the answer. यही तो मेरे को ढूंढना था ना. The only thing I had get to, what else are you supposed to find? I was supposed to find the value of phi only, and what is the value of phi I just got? 0. So what is the final expression? It will be x equal to a sine omega t plus, if I substitute phi by 0, I will get x equal to a sine omega t. Does it make sense, people? Yes? Now the question is, can we solve this same problem? Like, first of all, this is an easy problem. But anyway, can we solve this problem using some lesser number of steps? ठीक है, as it's a very easy problem, हो सकता है कि utility properly clear नहीं होगा. Again, I'll be taking a tougher problem after some time. But anyway, let's see if I can solve the same problem making use of this concept. Sir, what did you have on? Anyone wants to say something? My question is, I will try to solve the same problem, exactly the same problem, making use of this information that projection of UCM is an SHM. Okay? And let's see if we are going to get the same result or not. Okay? Listen to me very carefully. What was given in the problem, guys? Sir, in the problem, it was given that there is a particle performing SHM. X equal to plus A is the right extreme position, x equal to minus A is the left extreme position, and at t equal to 0, how is the particle present? At t equal to 0, the particle is present at x equal to 0, and the velocity is towards right omega. This was given in the problem, I guess. Everyone, this was exactly what was given in the problem. And what was I supposed to find out? I was supposed to find out the equation of the variation of x with respect to t, right? Now listen to me very carefully. Did we just study a few minutes before that projection of UCM is an SHM? Yes, sir. So, कौन सा UCM का projection will be this SHM? If I ask you, can you draw the UCM whose projection will be this SHM? Your answer will be yes, sir. मैं पूछूंगा, how will you do? आप बोलोगे simple, sir. जिस UCM का projection will be this SHM, na sir? Sir, that will look something like this. If you can draw a better circle, please do draw. That's the best I can do now. ठीक है? Now, center कहाँ था दोस्त? Sir, somewhere here. Babu, did we just see a few minutes before that the radius of this UCM will be same as the amplitude of the SHM? Yes, sir. Did we see कि if omega is the angular frequency of the SHM, same omega is the angular speed of the UCM as well? Did we see this just a few minutes before? Yes or no? Clear? Makes sense? Now listen to me. क्या बोलबो? चुपचाप सुन में. Listen to me very carefully. Babu, it is given in the. अच्छा, first of all, tell me what will be the general form. General form क्या आएगा इसका आंसर? आप बोलोगे सर it's a linear SHM with the mean position at x equal to 0. So general equation
omega t plus sin omega t plus
x equal to a sin omega t plus phi. And my like a is already given in the a as a only, omega is also used. So the only thing I have to find out is the value of phi. Now listen to me how I am calculating the value of phi. Listen. Babu, at t equal to 0, SHM wala particle is present here. Yes, sir. How will the UCM wala particle be present? अब बोलोगे सर दो पॉसिबल केस हो सकता है. मैं पूछूंगा कैसे. अब बोलोगे सर if the UCM wala particle is present here na sir, then also its projection will be here. Sir, if the UCM wala particle is present here na sir, then also the projection will be here. So there are two different possible positions of UCM for which I will get its projection at this point. Yes, sir. अब भाई दो पॉसिबल पोजीशंस ऑफ यूसीएम तो नहीं हो सकता ना फॉर अ पर्टिकुलर एसएचएम. दो पॉसिबल पोजीशन कैसा होगा? एक ही हो सकता है. So I basically have to find out कि which one is acceptable and which one is not. Listen to it. Babu, did I assume the UCM wala particle is moving in clockwise sense or anti-clockwise sense? What did I assume? Sir, clockwise sense. If the particle is present at this position, velocity कौन से direction में होगा? सर वेलोसिटी तो टेंजेंशियल होता है, हाँ वो तो मुझे ही पता है, लेकिन डायरेक्शन क्या होगा? सर क्लॉकवाइज में जा रहा है ना सर, इसका मतलब वेलोसिटी विल बी लाइक दिस सर, टुवर्ड्स राइट होगा सर. वेरी गुड. एंड व्हेन द पार्टिकल विल बी प्रेजेंट हियर, सर क्लॉकवाइज में जा रहा है, इसका मतलब वेलोसिटी होगा लाइक दिस. वेरी गुड. नाउ टेल मी, at this particular position the velocity has been given to be towards right or towards left? Sir, it has been given to be towards right. Very good. So which one is acceptable? This one is acceptable. This one is not acceptable क्योंकि इसका वेलोसिटी है towards left. Clear? हाँ सर वो तो ठीक है, लेकिन phi का वैल्यू क्या होगा? I will discuss, don't worry. But have you been able to understand कि why this particular position is acceptable and why not this one? Because at this position the velocity is towards left, but it was given in the problem that at t equal to 0, velocity of SHM is towards right. Yes or no? Make sense? Now listen to me very carefully. How will you get the value of phi? To get the value of phi, join the initial position of UCM with the center. Again, what did I say? To get the value of phi, what did I say? Join the initial position of UCM with the center. What is the initial position of UCM? Sir, this one. What is the center? This one. इन दोनों को join कर दो. Done, sir. Now, बाबू just think in your mind, अगर मैं इसको x axis मान लूं, इसको y axis मान लूं, which one is a positive y axis? Sorry, is एक इस तरह के क्वेश्चन सर. पॉजिटिव y axis mean this one sir ना, this is the positive y axis. Very good. What did I say again? Join the initial position of UCM with the center. हाँ सर वो तो ठीक है, ये blue वाला लाइन ही तो है सर. How much angle is this blue वाला line is making with the positive y axis? सर क्या बोल रहे हो सर? ये जो पॉजिटिव y axis है सर that same as the line which is joining the initial position of UCM with the center. I know. So again I am asking the same question. How much angle is the line joining the initial position of UCM with the center making with the positive y axis? सर दोनों तो same line है. I know. So what is the angle? 0 degree. So phi is 0 degree here. Phi is 0 degree here. So what is the final answer I am getting? X equal to a sine omega t plus 0 or simple x equal to a sine omega t. मतलब sir you are basically saying कि I will join the initial position of UCM with the center. Yes. Then I will check how much angle it is making with the positive y axis. Yes. And whatever angle it will make, that will be the value of phi. Exactly. अच्छा sir, let's say if your UCM wala particle had been present at this position at t equal to 0, then what would have been the value of phi, sir? Simple. Follow the same algorithm. Join the initial position of UCM with the center. Done, sir. How much angle it is making with the positive y axis? चलो मान लेते हैं कि पॉजिटिव y एक्सिस के साथ क्लॉकवाइज सेंस में इट इज मेकिंग एन एंगल ऑफ लेट्स से पाई बाय 3 or let's say pi by 6. Okay sir, if it is making an angle in the clockwise sense from the positive y axis, I'll be taking the value of phi to be plus. मतलब sir you are saying plus pi by 6, right? Yes. Then I'll be taking the value of phi to be plus pi by 6. अच्छा sir, मतलब let's say at t equal to 0 if the particle had been present at this position, sir. Simple. Again follow the algorithm. Join the initial position of UCM with the center. Done, sir. How much angle it is making with the positive y axis? सर दिस एंगल. हाँ वो तो पता है, लेकिन क्लॉकवाइज और एंटी
30.
क्लॉकवाइज. सर ये तो एंटी क्लॉकवाइज में बना रहा है ना. हाँ अगर पॉजिटिव वाई एक्सिस के साथ यू आर मेकिंग एन एंगल इन द एंटी क्लॉकवाइज सेंस, एन एंगल ऑफ पाई बाय 6, लेकिन कौन से सेंस में यू आर मेकिंग दिस एंगल? इन द एंटी क्लॉकवाइज सेंस. सो आई विल बी टेकिंग फाई टू बी माइनस पाई बाय 6. क्लियर? मेक सेंस? सर एक डाउट है. क्या डाउट है सर? Sir, suppose your particle at t equal to 0 is present here. Let's say at t equal to 0, your particle is present here. Okay, so So sir, follow the same procedure. Chalo, let's follow. Join the initial position of UCM with the center. Very good. Now, तो सर पॉजिटिव वाई एक्सिस के साथ क्लॉकवाइज में इट इज मेकिंग एन एंगल प्लस फाइव. यस सर, एंटी क्लॉकवाइज में भी तो इट इज टेकिंग एन एंगल ऑफ पाई सर, आई नो. तो सर मतलब व्हाट एम आई सपोज टू टेक? शुड आई टेक फाइव इक्वल टू प्लस पाई और शुड आई टेक फाइव इक्वल टू माइनस पाई? अब जो भी लोगे आंसर आएगा सेम, इट डजंट मैटर. Whatever you want to take, you can take. You will be getting exactly the same answer. Does it make sense, folks? Tell me. Is it clear? Are you being able to follow anything? Brothers and sisters, is it clear? Well, এই ভয় যাচ্ছে আমার? Hello?
Answer.
Let's solve a problem. Suppose Babu will be solving in both the approach. ठीक है, चलो let's take a problem. Again, same linear SHM. X equal to 0 is the mean position. X equal to plus A is the rightmost extreme position. X equal to minus A is the leftmost extreme position. चलो मान लेते हैं कि at t equal to 0, let's say your particle is present at a distance of a by 2 from the center, and let's say its velocity is towards right. Sir, how much is the velocity? That I don't know. All I know ki at t equal to 0, it is present at this point and its velocity is towards right. Okay? Question is again same. Let's calculate the equation of the variation of displacement with respect to time t. One information is given in the question: angular frequency of SHM is omega. This is given in the problem. ठीक है? इसका मतलब omega is given. Omega is already given in the problem. I can give the final answer in terms of omega. Or you can already see the amplitude is already given to be A only. Clear? Now, we'll be solving the problem in both the approaches. Let's come to method number one. Is it a linear SHM? Yes, sir. Is the mean position at x equal to 0? Yes, sir. Do I already know the generalized variation of displacement with respect to time for such an SHM? Yes, sir. What was that? Sir, that was x equal to a sine omega t plus pi, sir. Very good. X equal to a sine omega t plus pi. Take it. A is given in the problem. Yes, sir. Omega is also given in the problem. Yes, sir. So what you and me have to find out? Sir, we have to calculate the value of phi, sir. Chalo, let's calculate the value of phi. Kaise? Oh, there is an information given here. At t equal to 0, displacement of the particle from the mean position is a by 2. So, Babu, can I say if I put t equal to 0, then what is the value of x? 0 ka right side mein it is at a distance of a by 2. So x equal to plus a by 2. So can I say, ladies and gentlemen, when x equal to plus a by 2 and t equal to 0, this equation should be satisfied, because at t equal to 0, x equal to plus a by 2, na? A gets cancelled, so I am getting half equal to sine phi. But 0 से 2 pi radian के बीच how many angles do you get? जहाँ sin phi का वैल्यू हाफ आता है, probably दो वैल्यू. Guys, what are the two possible values? एक होता है 30 degree, which is pi by 6, and the other one is 150 degree. Anyone let me know if I am making any calculation error. 5 pi by 6 if I'm not wrong. Good. ठीक है. Now the question is, एक SHM में दो फाई तो नहीं हो सकता ना दोस्त. एक SHM में एक ही वैल्यू हो सकता है फाई का. So let's calculate which one is the acceptable value of phi and which one is not acceptable value of phi. कहाँ से मिलेगा? Answer is simple. Sir, make use of the information कि at t equal to 0, velocity is towards right. We haven't made use of this information yet, so let's try to make use of this. If you differentiate displacement with respect to time, what will be getting? Velocity, sir. और इधर साइन को डिफरेंशिएट करोगे तो क्या आएगा सर? कॉस आएगा. चेन रूल से आर्गुमेंट को डिफरेंशिएट करोगे तो क्या आएगा दोस्त? ओमेगा आएगा. Am I getting velocity equal to omega a cos omega t plus phi, ladies and gentlemen? Yes or no? Do I make sense? दोस्त, are you being able to follow? But if I put t equal to 0, क्या आ रहा है दोस्त आंसर? Velocity equal to omega a cos phi. Now listen to me very carefully. If I substitute phi by pi by 6, velocity का साइन क्या आएगा दोस्त? Sir, omega a is positive. I know. Sir, pi by 6 is an acute angle. I know. Sir, first quadrant में तो cos positive ही होगा. इसका मतलब velocity should be coming in positive sign, right? But if I substitute phi by 5 pi by 6, velocity will be coming with which sign? sir, second quadrant angle. I know. So second quadrant में the cos negative होता है. Absolutely. So velocity should be negative sign. Which one is acceptable, sir? Sir, it is given that at t equal to 0, velocity is towards right. Okay, so sir, इसका मतलब at t equal to 0, velocity should be coming with positive sign. Very good. So which one is the acceptable one? तो सर ये वाला नहीं acceptable होगा, ये वाला acceptable होगा. Very good. So what is the value of phi? Sir, pi by 6, sir. Very good. So what is the final answer? X equal to a sine omega t plus what is the value of phi we just got? Pi by 6 na ki? Anyone confirm me once? Keep elum. Pi by 6 pelam to na ki? अरे की पेलम रे. Have we got pi by 6? Anyone confirm me once?
Yes, sir.
ठीक है those, are you being able to follow? Yes or no? ठीक है. Can we try to solve the same problem using the second method? That is the projection of SHM is nothing but a UCM? Absolutely no, sir. You said the ulta. Projection of UCM is a SHM, is an SHM, right? Sure. How was the SHM, ladies and gentlemen? X equal to 0, x equal to plus a, x equal to minus a, t equal to 0 mein what is the particle present, guys? Those, what is the particle present at t equal to 0? X equal to a by 2. Are anyone tell me what is the value I got? Key diyeছিলাম problem what did I give? A by 2. A by 2 দিয়েছিলাম তো নাকি? At t equal to 0, the particle is present at this point, and what is the velocity direction? Towards right. My question is, sir, we know projection of UCM is an SHM. Yes, sir. I know, sir. Can you draw the UCM? Which projection is this SHM? Simple, sir. Yes. अब बोलोगे simple, sir. Just draw a circle. कोई भी सर्कल ड्रॉ कर दो. नो सर, जहां मेन पोजीशन था ना सर, इसके एग्जैक्टली वर्टिकली ऊपर ही सेंटर होगा सर. अच्छा अच्छा. एनी अदर कंडीशन? Sir, whatever is the amplitude of the SHM, na, sir, so same is the radius of the UCM. Very good. So radius of the circle is nothing but plus a. Any other condition? Sir, you told us ki whatever is the angular frequency of the SHM, same is the angular speed of UCM. I know. Was angular frequency of SHM given in the problem? हाँ sir, it was explicitly given कि angular frequency is omega. So if the angular frequency is omega, what is the angular speed of the UCM? Sir, omega only. ये किस तरीके का question है? So tell me something, ladies and gentlemen. If the particle is present at this position at t equal to 0, इसका projection कहाँ होगा दोस्त? मतलब in the sorry, उल्टा बोला मैं. Where should the UCM वाला particle be present so that its projection is here? अब बोलोगे सर दो possibility. If the UCM wala particle is here, then also projection here. If the UCM wala particle is here, there also projection here. ठीक है दोस्त, are you being able to follow? Yes or no? Clear? Now listen to me very carefully. भाई दो different position पे UCM का नहीं हो सकता है ना t equal to 0. For a particular SHM, there has to be a particular value of initial position of UCM only. Can we have two different possible positions of UCM? No, sir. तो कोई एक ही होगा? Yes, sir. So which one is acceptable and which one is not? Simple, sir. कैसे? अब बोलोगे सर आप ऐसे सोचो. कैसे? Sir, if the particle is present here, then its velocity should be tangential to the path like this. बाबू, if the UCM वाला particle is present here, इसका horizontal component of velocity should be towards right. ठीक है? No big deal, I guess. Makes sense till now? If the UCM वाला particle is here, velocity कैसा होगा? सर वेलोसिटी टेंजेंशियल टू द पाथ होता है सर, मतलब कुछ ऐसा, राइट? यस. तो हॉरिजॉन्टल कंपोनेंट कौन से डायरेक्शन में होगा? सर हॉरिजॉन्टल कंपोनेंट मतलब सर हॉरिजॉन्टल पोजीशन विल बी टुवर्ड्स लेफ्ट सर. वेरी गुड. व्हिच वन इज एक्सेप्टेबल? सर इट वाज गिवन इन द प्रॉब्लम एट t इक्वल टू 0 वेलोसिटी ऑफ SHM इज टुवर्ड्स राइट. यस सर. तो सर यूसीएम वाला पार्टिकल कुछ ऐसा होना चाहिए ना सर, सो दैट इट्स हॉरिजॉन्टल कंपोनेंट इज टुवर्ड्स राइट. आई नो. तो सर दिस वन इज एक्सेप्टेबल ना. आई नो. दिस वन इज नॉट एक्सेप्टेबल. क्यों? क्योंकि इधर हॉरिजॉन्टल कंपोनेंट इज टुवर्ड्स लेफ्ट, but it is given in the problem कि the velocity at t equal to 0 for the SHM is towards right. So this one is acceptable and this one is not. Any doubt, sir? Do I make sense? Yes or no? Clear? Now, how do you get the value of phi? What was the strategy? Anyone? Help me out. Anyone? How did you get the value of phi? Just tell me what algorithm
Join
we are
the
supposed to follow.
center with the endpoint.
Very good. That was the first point. He join the initial position of UCM with the center. Step number two, sir, find the angle made by this radius vector with the positive direction of y-axis. Which one is the positive direction of y-axis? सर ये था सेंटर, तो इसका ऊपर वाला पार्ट सर दिस वन इज अ पॉजिटिव डायरेक्शन ऑफ वाई एक्सिस. वेरी गुड. जितना मेरे को आता है, अच्छा लेट मी ड्रॉ अ बेटर सर्कल. लेट्स सी इफ आई कैन ड्रॉ अ बेटर सर्कल और नॉट. थोड़ा सा बेटर हुआ ना दोस्त? प्रोबब्ली एनीवन? थोड़ा सा बेटर हुआ क्या सर्कल? चलो लेट्स ट्राई टू फाइंड आउट दिस एंगल. कैसे? बेसिक ज्योमेट्री यूज कर. सर ज्योमेट्री तो नहीं आता. क्यों नहीं आता? Sir, we forgot geometry after we got 99% in class 10, sir. अच्छा अच्छा. So let's revise. If this much is a by 2, तो इतना तो just visually देख के I can make a comment ना. If this much is a by 2, this much will also be equal to a by 2 only. Yes or no? Clear? भाई और बहनों, what is the radius? Sir, radius तो a है. अच्छा अच्छा. अगर इस एंगल को मैं फाई मान लूं, तो कैन आई से sin phi equal to height upon hypotenuse? तो sin phi equal to what is height guys? A by 2. What is hypotenuse? A. So phi equal to क्या आ रहा है दोस्त? sin phi half और phi equal to 30 degree. 30 degree मतलब 30 degree मतलब pi by 6. भाई pi by 6 ही होता है ना कि 30 degree আসছে. 30 degree if I convert that into radian, how much I'll be getting? Pi by 6. तो बाबू द रेडियस वेक्टर पॉजिटिव वाई एक्सिस के साथ क्लॉकवाइज सेंस में इट इज मेकिंग एन एंगल ऑफ पाई बाई 6. सो एम आई सपोज टू राइट फाई विद प्लस साइन और माइनस साइन? सर यू टोल्ड अस पॉजिटिव वाई एक्सिस के साथ अगर क्लॉकवाइज में इट इज मेकिंग एन एंगल, आई विल बी टेकिंग दैट टू बी with positive sign. I'll be taking that with positive sign. So phi is nothing but plus pi by 6. So what is the final equation? X equal to a sine omega t plus pi by 6. Babu, using method 1, what did you get? Did you get the same value or did you get something different? Same आ गया. अरे बस सर दो प्रोसेस से सेम रिजल्ट आ रहा है. क्या मिरेकल. Aren't we supposed to get two different answers by using two different processes for the same problem? लेकिन here I am getting the same result by two different method. ऐसे कैसे? ये तो जो ब्रेन है ढोके, मतलब do you understand मतलब which part is supposed to be taken as a sarcasm and which part of my speech is not supposed to be taken as a sarcasm? Do you understand or मतलब you don't have a funny bone? What's the thing? ये কিছু কি বলি কিছু clear হয়? Am I audible guys? Is a voice coming? Confirm me once.
হ্যাঁ স্যার.
বুঝলে ভালো, না বুঝলে আরো ভালো. Is it clear? Can we move to the next problem? Has everyone been able to follow up to this guys? Can you move to the next problem? Chalo. The problem says, कौन सा problem do? अच्छा चलो, let's solve this one. Suppose there is a particle which is performing linear SHM. Min position is x equal to 0. X equal to plus a is the rightmost extreme position. X equal to minus a is the leftmost extreme position. अच्छा चलो, let's solve this. The question says angular frequency of simple harmonic motion is given as omega. ठीक है, तो omega is given in the problem. The question is saying at a particular time instant, let's say the particle is present here. Sir, at a particular मतलब t equal to 0. I don't know. All I know that at a particular position the particle is present at the left extreme position. इसको a नाम, अच्छा ये तो I have used ना, इसको p नाम दे देते हैं. ठीक है. At a particular instant the particle is present at point p and then it moves towards right, and after some time it reaches point q. ठीक है दोस्त. मतलब initially point p था, after some time when it is moving towards the main position, after some time it will be reaching point q. ठीक है. X coordinate of point q is given as, let's say, minus a by root 2. Clear? find the time taken by the particle to travel from P to Q. First of all, tell me, have you been able to understand the question? Is the question making any sense? Or the question is not making any sense in your life? Is it making any sense in your life, guys? Are you being able to follow the question? At a particular time instant, your particle was present at point P. उसके बाद क्या होगा? It is not supposed to sit there for always, right? It will be moving towards the mean position. After some time, when it travels towards the mean position, it reaches point Q, which has an x coordinate of minus of a by root 2. The angular frequency of the SHM is given as omega. My question is, what will be the time taken by the particle to travel from P to Q? Now, we can solve this problem by writing mathematical equations. We can absolutely do that. ठीक है? लेकिन हो सकता है कि that is going to take a comparatively greater amount of time. If you want to solve this problem by a shorter approach, it will be better if we try to approach the problem using the concept the projection of UCM is a SHM. Clear? I am not saying that this particular problem cannot be solved by writing mathematical equation. That's not what I am saying. Absolutely, it can be done. But the problem can be solved by a shorter approach in a smaller amount of time if you try to attempt the problem by using the concept that projection of UCM is a SHM. So chalo, let's try to solve. Have you guys written the question? Have you copied the question? I will scroll down. Chalo. Listen to me very carefully. What is the situation? सर सिचुएशन कुछ ऐसा था सर कि एक SHM था सर. हाँ वो तो मुझे भी पता है, लेकिन वो था कैसा? सर मेन पोजीशन था x इक्वल टू 0, राइट मोस्ट था x इक्वल टू प्लस ए, लेफ्ट मोस्ट था x इक्वल टू माइनस ए. अच्छा, उसके बाद अच्छा ड्रॉ करेंगे उसके बाद, लेकिन पहले मुझे बोलो, कैन यू ड्रॉ द UCM व्हिच प्रोजेक्शन इज दिस SHM? हाँ सर सिंपल. कैसे? सर कुछ ऐसे सर. Hopefully I don't need to explain anymore. I can directly draw कि the UCM वाला particle will be traveling in a circular path like this. And what will be the radius of that circular path? Will be same as the amplitude of SHM. Did you just see the radius of UCM is same as the amplitude of SHM? So this is A only. Clear? Now listen to me. Now, how was the particle present at t equal to, sorry, my mistake. How was the particle initially present? Sir, you said something like this कि at a particular time instant particle is present here. अच्छा इसको P नाम दिया था ना, if I'm not wrong. Guys, anyone just check and confirm me, was this denoted by point P? Yes. Where should the UCM of a particle be present so that its projection is at point P? Can I say the UCM of a particle is supposed to be present here? Yes or no? Everyone, does it make sense? If the UCM of a particle is present here, then only its corresponding projection will be formed here. Yes or no? Is it clear? Anyone, am I audible? Please confirm me once if I'm connected or not. Anyone? Is the voice coming?
Yes.
If the UCM wala particle is present here, then only its projection will be here. Yes, sir. But what happened after this? Sir, you said ki it will be moving towards the mean position. Absolutely. And you said ki after some time it will be reaching point Q. Yes, I said. What is the x coordinate of Q? Sir, you said ki x coordinate of Q is minus a by root 2. Very good. In which sense it was the UCM was making the rotation? The UCM was rotating in the clockwise sense, right? Angular frequency of the SHM was given omega. So what should be the angular speed of the UCM? Sir, omega only. Very good. So Babu, can you tell me ki where should the UCM wala particle be present such that its projection is formed at Q? अब बोलोगे सर दो possible answer हो सकते हैं. कौन सा दो? Sir,
Second
if the
quadrant.
particle is present here, then also Q is here. If the UCM वाला particle is here, then also यार ना मेरा आंसर होगा भाई दो तो नहीं हो सकता ना, एक ही हो सकता है. तो मतलब कौन सा होगा? बोलेगा सर थोड़ा सा कॉमन सेंस यूज करो। मैं बोलूंगा भाई है नहीं मेरे पास कॉमन सेंस, तू ही मुझे बता, हाउ एम आई सपोज टू नो? सर यू ओनली टोल्ड अस ना इट इज रोटेटिंग इन द क्लॉकवाइज सेंस। सर अगर क्लॉकवाइज सेंस में रोटेट कर रहा है तो फ्रॉम दिस पोजीशन इट विल बी ट्रेवलिंग टू दिस पोजीशन ना सर। क्लॉकवाइज सेंस में रोटेट कर रहा है सर, तो obviously this one is not acceptable, the bottommost one. Clockwise में अगर rotate कर रहा है from this point it will be traveling to this point only. Yes or no? Makes sense? Hopefully no doubt. So ladies and gentlemen, can I make a comment? Sir, which comment? Can I make this comment? Sir, which comment? Can I make this comment कि when the UCM वाला particle will be traveling from the point P prime to the point Q prime, then its projection will be traveling from point P to point Q. Yes or no? Yes or no? Anyone? Can I say this? If when the UCM molar particle will be traveling from P prime to Q prime, then only the SHM molar particle will be traveling from point P to point Q. Yes or no? Yes, sir. Okay. So, Babu, instead of calculating in terms of SHM, can't I simply calculate how much how much time it will be taken by the UCM molar particle to travel from P prime to Q prime? हाँ sir, we can do. हाँ वी कैन डू, लेकिन कैसे वी कैन डू? हाउ कैन यू डू? सर ज्योमेट्री सर। हाँ वो तो मुझे ही पता है, लेकिन कैसे? अब बोलोगे सर सी पी प्राइम पॉइंट का एक्स कोऑर्डिनेट क्या था सर? माइनस ए, सो हाउ मच इज दिस मच लेंथ? ए ओनली। लेट मी यूज अ डिफरेंट कलर, लेट मी यूज अ डिफरेंट कलर। हाउ मच इज दिस मच लेंथ? ए सर, वेरी गुड। हाउ मच इज दिस मच लेंथ? सर सर दिस मच लेंथ इज योर ए बाई रूट टू। आई नो। तो सर from basic geometry, sir this much length should be a by root 2 only. Very good. So what am I supposed to calculate? Sir, you are supposed to calculate how much angle the radius vector has traveled or rotated by from p prime to q prime. Yes sir. लेकिन कैसे कैलकुलेट करेंगे? बोलोगे सर बेसिक ज्योमेट्री। हाँ लेकिन कैसे? सर आप मान लो कि दिस एंगल इज थीटा। वेरी गुड। तो व्हाट इज साइन थीटा लेडीज एंड जेंटलमैन? साइन जितना मेरे को आता है, साइन होता है हाइट व्हिच इज a upon root 2 divided by hypotenuse. And how much is this much length? Is it a guys? So is theta coming out to be pi by 4 radian? हाँ sir. So the theta is nothing but 45 degree. जितना मेरे को मैथ्स आता है ना सर, this total angle is 90 degree. Okay sir. अगर if this much is 45, how much should be this much? सर 90 minus 45 कितना होता है? 90 minus 45 45 only, or pi by 4. So can I say ladies and gentlemen, the time taken by the UCM, sorry, the SHM molar particle to travel from P to Q, it's same as the time taken by the UCM molar particle to travel from P prime to Q prime. And how much is the time taken by the UCM molar particle to travel from P prime to Q prime? The same time in which the radius vector rotates by an angle of 45 degree or pi by 4 radian. How much is the time taken then? Simple, sir. Pi by 4 is the time angle traveled, divided by what is the angular speed with which it is traveling? Omega, sir. So how much time it will be taking? Sir, pi by 4 omega. So from here to come here, it will be taking an time of pi by 4 omega. Anyone just check the calculation and confirm me. Are we getting pi by 4 omega? Yes or no? Anyone confirm me once? Are we getting the answer pi by 4 omega? Yes. Am I audible, guys? Is a voice coming? Hello.
Yes, sir.
All of us are getting the same result? Anyone getting some different result? Please let me know. We can have a small discussion on that as well. Is it clear? Can you move to the next people? बोल रे भाई क्लियर हुए छे? Hello. Anyone who couldn't follow anything? अच्छा मतलब ऐसे कैसे कि मतलब you people are not having any doubts? मतलब जीनियस तो तुम लोग हो नहीं, ठीक है? एक भी डाउट नहीं आ रहा है फिर? मतलब छोटा तो डाउट हो सकता है ना, मतलब नॉट अ सिंगल डाउट। चलो गुड थिंग, सबका मेंस में 99.5 आएगा। चलो इन द नेक्स्ट मेंस लेट्स सॉल्व अ प्रॉब्लम। अ पार्टिकल, अच्छा just give me 1 second, just this problem is done. अच्छा, थोड़ा सा और थ्योरी पढ़ लेते हैं, उसके बाद आई विल अगेन कम बैक टू न्यूमेरिकल्स. Let's read a bit of theory. Okay, listen to it. Let's start the next part, something called as the energies of SHM. What are you going to study, guys? क्या पढ़ेंगे हम? We'll study energy of SHM. We'll again come back to numericals. ठीक है, थोड़ा सा theory पढ़ लेते. Let's come to energy of SHM. बाबू भाई, energy of SHM we mean the mechanical energy of SHM. ठीक है. What is the total mechanical energy of a particle performing SHM? Simple. So total mechanical energy क्या होगा? Sum of kinetic and potential energy. Very good. So let us start the topic with the kinetic energy of SHM. Although we will study when a particle is performing linear SHM, how does its kinetic energy varies with respect to different parameters. ठीक है sir? Not a big deal. चलो, let's solve this. Suppose a particle is performing linear SHM, min position is at x equal to 0, rightmost is x equal to plus a, leftmost is x equal to minus a. Okay. So did we have a general equation regarding the variation of displacement with respect to time? And what was that? Was it x equal to a sine omega t plus phi? Was this the equation, guys, that shows the general variation of displacement with respect to time? This was the one, I guess. Phi was the initial phase, omega is the angular frequency, a is the amplitude. Yes. What is the expression for velocity? Simple, sir. You differentiate the displacement with respect to time, you will be getting velocity. How much I'll be getting? A into sine को differentiate करोगे तो क्या आएगा सर? Cos omega t plus phi into chain rule से इसको differentiate करोगे तो क्या आएगा? और एक ओमेगा आएगा. तो velocity comes out to be omega a cos omega t plus phi. Ladies and gentlemen, is this the equation that shows the variation of velocity with respect to time for a particle performing linear SHM with a mean position at x equal to 0? Yes or no? ठीक है. Anyone, any doubt? Is it clear? Have you been able to follow? Babu, did we have another equation of velocity with respect to the displacement from mean position? Does anyone just check? Did we also have a result how the speed varies with respect to displacement from mean position? Was it omega into square root of s square minus x square? Anyone confirm me once? Did we also have this equation showing the variation of speed with respect to the displacement from mean position? Did we have this? Anyone confirm me? Yes or no? Am I audible? Am I connected to you people? Hello? Is the voice coming properly, guys? No. Babu, I want to get an expression of kinetic energy with respect to time. आप बोलोगे सर सिंपल. मैं पूछूंगा कैसे? आप बोलोगे सर काइनेटिक एनर्जी का एक ही फॉर्मूला होता है, हाफ इंटू मास इंटू स्पीड स्क्वायर. What is the variation of velocity with respect to time? Do we already have an expression for the variation of velocity with respect to time? Yes, sir. चलो लिखो. सिंप्लीफाई करोगे तो क्या आएगा सर? हाफ m ओमेगा स्क्वायर a स्क्वायर cos square omega t plus phi. Yes or no? Any doubt up to this? ठीक है. Now, there are few observations that I need to get out of this equation. What are the observations I can make from this equation? Listen to me. जितना मेरे को मैथ्स आता है, cos of something always varies in the range from -1 to +1. सर वो तो हमें भी आता है, I know. तो cos स्क्वायर कौन सा रेंज में वेरी करेगा? सिंपल सर, cos स्क्वायर है तो मिनिमम वैल्यू 0 होगा और मैक्सिमम वैल्यू आई विल बी गेटिंग 1. दोस्त जब cos of omega t plus phi +1 और -1 होगा तब cos square will be giving me the maximum value. So this particular expression is varying in the range from 0 to 1. Yes sir, we know sir. So tell me, this whole damn expression is varying in which range? Simple sir, minimum 0 होगा और maximum sir maximum तब होगा ना when this quantity will be 1. Yes, उसका मतलब what will be the maximum value? Sir, maximum value is half m omega square a square. Very good. We will remember the result. Sir, which result? we'll remember the result that kinetic energy varies in the range from 0 to half m omega square a square. If someone has a bit of common sense, he will be telling me, sir, we already knew this from the last session. कैसे? सर क्या बोल रहे हो? काइनेटिक एनर्जी कब मिनिमम होता है सर? जब स्पीड का मिनिमम वैल्यू क्या होता है? जीरो होता है. कब होता है? एक्सट्रीम पोजीशन में होता है. वेरी गुड. मिन पोजीशन में स्पीड मैक्सिमम होता है. व्हाट इज द स्पीड एंड मिन पोजीशन? ओमेगा है, तो काइनेटिक एनर्जी का मैक्सिमम वैल्यू क्या होगा? हाफ एम ओमेगा स्क्वायर स्क्वायर. व्हाट्स द बिग डील सर? सर यू आर नॉट टीचिंग अस एनीथिंग न्यू सर. दिस इज समथिंग वी हैड ऑलरेडी लर्नड इन द लास्ट क्लास. चलो ठीक है. ओके, लेट्स सी इफ आई कैन we can discuss something new. The first thing we have got the kinetic energy varies in the range from 0 to half m omega square a square. Any doubt up to this? No, sir. Now listen to me very carefully. अच्छा, before that, is there some mathematical expression कुछ ऐसा है क्या मैथ में? I think cos square theta को sum 1 plus cos 2 theta by 2. Do you have something like this in math? है क्या मतलब? Can anyone confirm me? Do we have something like this in math? और probably sin cos theta को लिखते हैं 1 minus cos 2 theta by 2. है ऐसा दोस्त, ठीक है? Guys, can I make use of this expression to expand this term? If I make use of this expression to expand this term, क्या मिलेगा मुझे? हाफ m ओमेगा स्क्वायर स्क्वायर. दोस्त, ये जो पूरा आर्गुमेंट है ना सर, ये पूरा आर्गुमेंट को आप थीटा मान लो. If you consider the whole argument to be theta, can I say if I expand this, I'll be getting 1 plus cos of multiply the whole argument by 2. So it will be 2 omega t plus 2 phi by 2. Have I done it right, guys? Any doubt? Dost, have I done it right? Yes or no? Let's try to simplify this. क्या आएगा? 1 by 4 m omega square a square into 1 plus cos of 2 omega t plus 2 phi. Have I done it right? Anyone? Let's multiply, guys. Let's multiply. Let's distribute this over the two terms. तो k equal to क्या आएगा? 1 by 4 m omega square a square plus 1 by 4. Babu, anyone just check the calculation and confirm me. If you যদি কোনো calculation mistake হয়, please let me know immediately. Half m omega square a square into cos of 2 omega t plus 2 theta. Now listen to me very carefully what I am saying. Listen. Let's look at this expression and tell me, can I say that kinetic energy has been expressed as sum of two terms? हाँ sir. One term, other term. Very good. Can you observe that one of the terms is a constant? हाँ sir. 1 by 4 m omega square a square. Sir, this is not varying with time. This is a constant term. Yes. Is the other term varying with time? हाँ sir. So this term is varying with time. Very good. But the term which is varying with time is this a periodic function? Sir, I didn't understand. I am asking the term which is varying with time. Which term is varying with time? 1 by 4 mm omega square square. This is a term varying with time. Yes. Is this varying periodically with respect to time? अब बोल के हाँ sir. मैं बोलूँगा how did you know it's varying with periodically with respect to time? Sir, cos of a linear function of time is given na. Sir, cos of a linear function of time, sir, it's a cosine function of time, sir. Yes, so, sir, cosine function of time is a periodic function. Very good. Which means, sir, which means this function, matlab sir, this term is a periodic term, sir. By periodic term, you mean it is varying periodically with respect to time. Yes. In class 12, your respective math teachers will be teaching you in graphical transformation. Whenever you add a periodic term with a constant term, what am I saying? Whenever you add a periodic term with a constant term, the resultant sum is also a periodic term. Okay. Whatever is the time period of the periodic term, same is the time period of the sum. Guys, what is the time period of this term? सर टाइम पीरियड का तो एक्सप्रेशन कुछ ऐसा था ना सर, 2 पाई बाई ओमेगा. हाँ, लेकिन व्हाट इज द वैल्यू ऑफ ओमेगा हियर? Sir, you said something like this. whatever is the coefficient of t, that is supposed to be taken as omega. I know. What is the coefficient of t here? Sir, 2 omega, sir. Very good. So what is the angular frequency corresponding to the variation of this term? What is omega corresponding to this term? Don't say omega. It is twice omega. So what is the time period of variation of this term? Sir, pi by omega. So what is the time period of variation of this overall term? Same, pi by omega. Now listen to me very carefully. Babu, what was the expression of displacement with respect to time? X equal to a sine omega t plus phi. Am I right? What is the angular frequency corresponding to this term? Sir, omega, sir. So what was the time period corresponding to the variation of displacement? Sir, 2 pi by omega, sir. Very good. What about velocity, guys? What was the expression for velocity? Sir, omega a cos omega t plus phi, sir. Okay. What is the angular frequency? Sir, time ka coefficient is omega. Very good. So angular frequency of variation was omega. So what is the time period corresponding to the variation of velocity? Sir, 2 pi by omega. Very good. What about acceleration, guys? Can anyone confirm me what was the expression for acceleration? Was it minus omega square a into sine omega t plus phi? What is the coefficient of time? Omega, sir. So what is the angular frequency of variation of acceleration? Omega, sir. So what is the time period corresponding to the variation of acceleration? 2 pi by omega, sir. So can I make an observation, guys? For displacement, velocity, and acceleration, for all these three physical quantities, angular frequency was omega. Omega, time period 2 pi by omega. But for kinetic energy, for the variation of kinetic energy, what is the angular frequency we just observed? Anyone? Same as this term. And what is the angular frequency corresponding to the variation of this term? 2 omega. So corresponding to kinetic energy, what is the angular frequency of variation? 2 omega. And time period is pi by omega. So we have to make an observation. What is that? In an SHM, displacement, velocity, acceleration, for all these three terms, okay, sir, for all these three terms, angular frequency is omega, time period 2 pi by omega. But the kinetic energy has an angular frequency of twice omega and time period of pi by omega. Sir, we do understand that. Achha, what about frequency then, by the way? Sir, frequency matlab f, right? Yes. Sir, frequency to 1 by time period hota hai. Very good. So omega by 2 pi, omega by 2 pi, omega by 2 pi, and omega by pi. Now listen to me very carefully. Well, what does frequency imply? Sir, frequency gives us an idea how quickly a physical quantity, how rapidly a physical quantity is varying. Okay. So displacement, velocity, acceleration, for all these three, angular frequency was omega. Fine. Lekin sir, for kinetic energy, the angular frequency is 2 omega. Can I say this implies this implies the kinetic energy is varying at a rate, in a very lame language, kinetic energy is varying at a rate which is double that of the variation of displacement, velocity, and acceleration. जिस rate से displacement, velocity, and acceleration are varying, kinetic energy is varying at a rate double of that with respect to time. Yes, sir. Makes sense or not? जिस रेट से डिस्प्लेसमेंट, वेलोसिटी एंड एक्सीलरेशन आर वेरी, काइनेटिक एनर्जी उसका डबल रेट से वेरी हो रहा है. यस और नो? मतलब जिस टाइम पीरियड में, जिस टाइम में डिस्प्लेसमेंट, वेलोसिटी एंड एक्सीलरेशन विल बी finishing one cycle, kinetic energy will be finishing 2 complete cycles within that time. Yes or not? Any doubt? Have you been able to understand, guys? Yes or no? Does it make sense?
Sir, আরেকবার repeat করবে এটা বললে?
So from this we observe that as the angular frequency of kinetic energy is double that of displacement, velocity, or acceleration, this means just time mein, the time within which displacement, velocity, and acceleration will be finishing one complete cycle, kinetic energy will be finishing two complete cycles of variations. ठीक है, क्योंकि वो डबल रेट से वैरी हो रहा है. Make sense? Sure.
Yes, sir.
Now let's spend some time on this result. So guys, have you been able to understand up to this? First we had observed कि kinetic energy vary कौन से range में होगा. Then we made an observation कि displacement, velocity और acceleration जिस rate से vary हो रहा है, for linear SHM kinetic energy will be varying at a rate double of that. Clear? Now, Babu, I want to get an expression of how kinetic energy is varying as a function of displacement from the mean position. How will I get? So simple, sir. Kinetic energy is half into m into v square. वो तो मुझे भी पता है. Someone who is in class 8 उसको भी पता होगा. Sir, you want the kinetic energy as a function of x? Yes. So sir, simple. You know the expression of velocity as a function of x. I know. लिख दो sir. You know the expression of velocity as a function of x. Guys, what is the expression for the variation of velocity as a function of x? Was this the one? Yes sir. सॉल्व करेंगे तो क्या आएगा? थोड़ा सा सिंप्लीफाई करेंगे तो हाफ एम ओमेगा स्क्वायर इनटू स्क्वायर रूट को अगर स्क्वायर करोगे सो स्क्वायर रूट रिमूव हो जाएगा क्या दोस्त? Does it make sense? Yes or no? Now think with me a bit. दोस्त x कौन से रेंज में वैरी होता है? अच्छा, let's think in this fashion first. First tell me for mean position. At mean position, what is the value of x? Sir, mean position में तो x is 0. Very good. What is the kinetic energy? So simple, put x equal to 0, you will get half m omega square a square. Sir, what's the big deal? No big deal. But as the particle moves away from the mean position, either towards right or towards left, I don't know. But when the particle moves away from the mean position, can I say guys, as the particle moves away from mean position, can I say mod of x will increase? Sir, why are you saying mod of x? Because those it can move towards the right side of x equal to 0, it can also move towards the left side of x equal to 0. I am saying when it moves away from mean position, away from x equal to 0, can't I say that mod x increases? Ha sir, you can say sir mod x increases. But if mod x increases, can I say this will imply that x square increases? Yes sir. If x square is increasing, can I say guys a square minus x square is decreasing? Yes sir. If a square minus x square is decreasing, can I say this will imply that kinetic energy is decreasing? Yes sir. So can I make this observation, ladies and gentlemen, as the particle moves away from the mean position, kinetic energy decreases? आप बोलोगे sir, we knew this sir. अरे वो तो मुझे भी पता है, you knew. It's just that we are explaining in a different fashion. At mean position, kinetic energy is maximum, which is half m omega square a square. As the particle moves away from the mean position, the speed decreases. Speed decreases matlab kinetic energy also decreases. But when the particle reaches the extreme position, मतलब जब x का वैल्यू प्लस है और माइनस है होगा, पुट x इक्वल टू प्लस है और माइनस है, व्हाट इज द वैल्यू ऑफ काइनेटिक एनर्जी यू आर गेटिंग? 0. तो ये तो होना भी चाहिए था. व्हाट्स द बिग डील? क्लियर? डज इट मेक सेंस गाइस? यस. नाउ Babu, I want to draw a graph. Sir, between whom? Babu, I want to draw a graph showing the variation of kinetic energy in terms of x. I want to see how the kinetic energy varies as a function of x. Clear? सर ड्रॉ कर दो. हाँ वो तो ड्रॉ करूंगा, लेकिन कैसे? अब बोलोगे सर ऐसे सोचो.
तो बेटा बोला
Kinetic energy is given as half m omega square a square minus x square. Sir, I am plotting kinetic energy along y-axis. तो just think कि y is written in place of k. Ladies and gentlemen, इसको multiply कर दो. half m omega square a square. This whole part is a constant. c1 मान लो minus half m omega square x square. This whole part can I think in this way? C2 into a square. C2 is the half m omega square part. Can I say this whole expression can be written in this format? Y equal to C1 minus C2 x square. Ladies and gentlemen, y is given as a quadratic function of x. This implies the variation of y in terms of x will be that of a parabola. सर कैसे? आई डोंट नो, योर मैथ्स टीचर नोस, आस्क हिम और हर। मेरे को सिर्फ इतना आता है कि इफ y इज वेरिंग एज अ क्वाड्रेटिक फंक्शन ऑफ x, आई नो कि द वेरिएशन इज दैट ऑफ अ पैराबोला। ठीक है, नाउ द सेकंड पॉइंट, I can see y is given as a linear term and x is present as a quadratic term. Yes sir, मेरे को इतना आता है एज अ physics mentor who has been teaching for almost 10 years for JEE, इतना मेरे को आता है कि if linear y is varying as a quadratic function of x, this will be a vertical parabola. Vertical मतलब इतना आता है कि either upward open होगा or it will be downward opening. नेक्स्ट आई ऑब्जर्व कि एक्स स्क्वायर का कोएफिशिएंट इज नेगेटिव, y का कोएफिशिएंट व्हेन मेड पॉजिटिव देन एक्स स्क्वायर इज हैविंग अ नेगेटिव कोएफिशिएंट. If y's coefficient positive makes x square's coefficient negative, this is the expression of a downward parabola. ठीक है, so मोटा मोटा the bottom line is this expression will be that of a downward opening parabola. ठीक है सर, चलो let's draw. It will be that of a downward opening parabola. But did we already make this observation? See, I am explaining in such a way that those of you who haven't done this particular chapter called parabola in maths, they can also understand. Okay? If this had been a pure, if all of you had done parabola, then probably I would have explained in a different fashion. But even if you don't understand parabola, I hope that this explanation will make you convinced that this is the expression of a parabola. Did we observe that at x equal to 0, kinetic energy is maximum? Did we just get this? At x equal to 0, kinetic energy is maximum, and as x increases in terms of magnitude, kinetic energy drops. At x equal to plus minus a, the kinetic energy becomes 0. Parabola का shape कैसा होगा? I am hoping that this is not the first time you are hearing this term called as parabola. Multiple times you have observed this particular figure. x equal to 0 में kinetic energy is maximum. दोनों side में it drops. That will be the shape. ठीक है, x equal to minus a में it becomes 0, x equal to plus a में at the right extreme position it becomes 0. Main position which is at x equal to 0, kinetic energy is maximum. Guys, what was the maximum value of kinetic energy? Half m omega square square. This is the variation of kinetic energy as a function of x. Any doubt, sir? Does it make sense? Yes or no? Tell me. Any doubt? Have you been able to follow everything till now? Yes or no? Am I audible, guys? Am I connected to you people? Voice আসছে? Anyone confirm me once? Am I audible? Is the voice coming? Hello?
Yes.
Next. We have finished the discussion of kinetic energy. Now let us go to potential energy. Let's see how the potential energy varies. So the next discussion is of potential energy of SHM. Chalo. Listen to me. Same figure, x equal to 0 is the mean position, x equal to plus a is the right extreme position, x equal to minus a is the left extreme position. And what is the angular frequency of SHM? So angular frequency of SHM is omega. Very good. Ladies and gentlemen, what was the variation of acceleration? আমাকে দুটোই বল, as a function of time ও বল, also tell me as a function of, আচ্ছা চলো let's start with x first. How acceleration was varying as a function of x? We said we started with that only. Acceleration varies as minus of omega square into x. Guys, was this one of the condition of SHM? Did we say this? Ki acceleration has to be directly proportional to the displacement from mean position. Did we say this? Ki k by m was I think replaced by omega square. And what the minus sign implied? The minus sign implied the acceleration is acting in a direction opposite to that of displacement from mean position. Okay? Now, but suppose there is a particle present at point P whose mass is m. From the mean position, it is displaced towards right by a displacement of x. If the particle is displaced to the right from the main position, force कौन से direction में होगा? Towards left. क्यों? Sir, we saw ना मतलब the first condition of SHM, sir. So the restoring force is always towards the main position. It is always opposite to the direction of displacement from main position. So what is the force acting on the particle? Sir, force होता है mass into acceleration. I also know. What is acceleration? Minus omega square x. So force equal to minus m omega square x. Yes, sir. But in work per energy, did we get a relation between force and potential energy? Anyone in work per energy chapter, did we get an expression for the variation of force as a function of potential energy? Did we see this? If F equal to minus del u del x I cap minus del u del y j cap minus del u del z k cap? Yes, sir. But in this case, the motion is constant along a single dimension, which is x-axis. So I will write just F equal to minus du dx. Any doubt? Okay, makes sense. Minus minus gets cancelled from both sides. So du will be m omega square x dx. Let's integrate. This part is constant. Let's keep it out of the integration sign. Babu, have we mentioned this multiple times? Ki potential energy is a relative quantity. Sir. Did we say this almost 1 billionth plus one time? Did we say this 1 billion plus one time? Ki whenever we have to get the absolute value of potential energy, first we need to define a reference where the potential energy will be assumed to be zero. Ha, sir. But sir, you didn't say this 1 billion plus one time. You said this 1 billion plus third time. And now 1 billion plus fourth time. But still some of you haven't retained. So in this case also, I have to decide which position I will be considering to be the reference position. And the convention is we consider x equal to 0, the mean position is the reference position, and at the mean position we assume the potential energy is 0. Okay? Okay, sir. So at x equal to 0, we consider the potential energy is 0. And at some arbitrary value of x, we assume the potential energy is u. Yes, sir. Now integrate. Du का integration क्या होगा? U होगा, lower limit 0, upper limit u. X का integration क्या होगा? Sir, x square by 2 होगा, lower limit 0, upper limit x. Put the upper limit minus lower limit. U minus 0 equal to half m omega square. Put the upper limit x, lower limit 0, x square minus 0 square. So result is coming. Final result we are getting. Potential energy U is varying as half m omega square x square. Yes or no? ठीक है दोस्त? Yes, sir. Can you draw a graph showing the variation of the potential energy as a function of x? Yes, sir. How will it vary? Simple, sir. हाँ, simple तो है, लेकिन how will it vary? Sir, you are plotting u along y-axis, you are plotting x along x-axis. So this equation resembles the form y equal to some constant times x square. जितना मेरे को maths आता है, y equal to some quadratic function of x and x square का coefficient is positive. This is that of a parabola opening upward. Yes, sir. और अगर some of you have a common sense, you will be telling me, sir, ये तो standard parabola था ना sir, x square 4ay फॉर्म का, जिसका भाट x प्रेजेंट था at x equal to 0, y equal to 0 at the origin. So the parabola will be looking something, sorry, this is not a parabola. The parabola will be looking something like this. ठीक है? Babu, should I put dot dot sign on both sides? Absolutely no, sir. Sir, why? Why not dot dot? Because sir, x is can vary only from minus a to plus a, na? Why? Why x can will only vary from minus a to plus a? Sir, the left extreme position is at x equal to minus a. So the right extreme position is at x equal to plus a. So sir, the particle is only constrained to remain between x equal to minus a and x equal to plus a. Okay? So this is a variation of the potential energy as a function of x. Does it make sense? Yes, sir. Babu, I have got an expression for kinetic energy as a function of x. What was that? Half m omega square minus x square. I have got an expression of the variation of potential energy as a function of x, which is half m omega square x square. Can we just calculate the sum of the kinetic and potential energy to get the total mechanical energy? What will be this, guys? If I add this to, is it coming out to be half m omega square a square? But is the total mechanical energy coming out to be constant or it is varying as a function of x? Sir, the total mechanical energy is constant, sir. Shocking or this is totally expected? This is totally expected. Why was it expected that the total mechanical energy will be constant? Because sir, the total mechanical energy will be conserved now. That I know. लेकिन how did you know कि the total mechanical energy will be conserved? Simple, sir. कैसे? Sir, in work power energy, you told us almost 897 times during the chapter कि conservation of mechanical energy happens under two conditions. Number one, no dissipative force. Number two, work done by external force is zero. Okay. Was there any dissipative force in this picture, sir? No dissipative force. Was there any external force in the figure? अब बोलोगे sir, sir, this force is to be treated as internal, na sir? Yes. Hopefully, I will not explain anymore ki why is this supposed to be treated as internal. Multiple times we have discussed why this is the internal force. Clear? So what is the work done by the external force? Zero, sir. Any dissipative force in the picture? No, sir. So should the total mechanical energy be conserved? Yes, sir. So are we supposed to expect the total mechanical energy will be coming out to be a constant value? Yes, sir. Are we getting the total mechanical energy as a constant value? Yes, sir. So are we supposed to be shocked? Sir, unless we are completely shameless person who have forgotten the concepts of work per energy, we are not supposed to be shocked that we are getting a constant value. Sir, we are supposed to get a constant value of total mechanical energy. Very good. I want to draw a graph of what? I want to draw a graph of kinetic energy, potential energy, and mechanical energy as a function of x. Sir, we already did that. I know. We did that individually. I want to draw the variations of kinetic energy, potential energy, and mechanical energy in the same graph. लेकिन sir, why? ऐसे ही. What is the time now? 12:10 नहीं? So 12:10 में what should we do? We should draw graphs. What's the best way of spending post 12 o'clock other than doing graphs? So let's draw graphs. In the same graph, we'll be plotting the variation of kinetic energy, we'll be plotting the variation of potential energy, we'll be plotting the variation of mechanical energy. Chalo, let's do it. Babu, just check your copy and confirm me, was this the variation of kinetic energy as a function of x? Anyone? Confirm me once. Was this the variation of kinetic energy as a function of x? Anyone check the graph of kinetic energy variation and please confirm me, was this the variation of kinetic energy as a function of x? Can anyone confirm me? Anyone? What is the variation of kinetic energy? Babu, was this the variation of potential energy as a function of x? Confirm me once. Was this the variation of potential energy as a function of x?
Yes.
And what is the constant value of mechanical energy? Half m omega square. So if something is constant, then how should the graph of that be? Parallel to the independent variable axis, that is a parallel to x-axis. So how should the graph of total mechanical energy be? Like this? Yes or no? The graph should be like this? Yes or no? This is the variation of kinetic energy, variation of potential energy, and the variation of total mechanical energy. Clear? Babu, check the mean position. This is the mean position, guys. X equal to 0. At the mean position, do I observe that the kinetic energy is minimum? No, sir. Kinetic energy is maximum. Achha. So mean position mein kinetic energy is maximum. Very good. Look at the graph of potential energy and tell me, can I observe at the mean position potential energy is minimum? Yes, sir. Look at one of the extreme position. Is the kinetic energy maximum? No, sir. Sir, kinetic energy is minimum, sir. 0, sir. Okay. Kinetic energy minimum. And what about the potential energy? Potential energy is maximum, sir. Yes or no? Does it make sense till now? Yes or no? Is it clear, guys? In the same graph, we have plotted the variation of kinetic, potential, and the total mechanical energy. Any doubt up to this? Okay. Have you been able to follow up to this? Anyone? Guys, kinetic energy was varying in which range? Anyone? What was the range of variation of kinetic energy? 0 to
half
half
omega
m omega square a square. So similarly, look at potential energy. Just look at this expression. What is the maximum value of x square? A square. कब मिलेगा? Sir, when x is plus or minus a. So mota, can I make this comment that the potential energy will also vary in the range? Same. 0 to half m omega square a square. But what about the total mechanical energy? Is the total mechanical energy is varying in a range or it is giving me a constant value? Sir, it's giving me a constant value. And what is the constant value? Sir, half m omega square square. Acha, acha, acha. ठीक, ठीक. Next. Babu, I want to get an expression of the variation of potential energy as a function of time. Sir, as a function of time? Yes, sir. But sir, you already have the variation as a function of x. I know. Then sir, why do you need the variation as a function of time? ऐसे ही मेरा मर्जी मेरा लाइफ मेरा डिमांड आपको क्या आई वांट टू गेट अ वेरिएशन ऑफ पोटेंशियल एनर्जी एज अ फंक्शन ऑफ टाइम ठीक है चलो लेट्स डू इट variation of potential energy as a function of x is given as half m omega square x square. So that too we know. But do I already know how x is varying as a function of time? Yes, sir. Substitute by that expression. How is x varying as a function of time, guys? A sine omega t plus theta. Yes or no? So u coming out to be equal to half m omega square a square sine square omega t plus theta. सर ठीक है लेकिन मतलब व्हाई डू यू नीड दिस ऐसे ही अच्छा बाबू जस्ट टेल मी फ्रॉम हियर कैन वी कंफर्म फ्रॉम दिस एक्सप्रेशन कि u इज वेरिंग इन व्हिच रेंज साइन स्क्वायर का मिनिमम वैल्यू क्या होता है 0 साइन स्क्वायर का मैक्सिमम वैल्यू क्या होता है 1 सो ये जो टोटल एक्सप्रेशन है इसका मिनिमम वैल्यू क्या होगा 0 मैक्सिमम वैल्यू क्या होगा half m omega square into 1 matlab half m omega square. So can we justify from this expression as well that u is varying in this range only? Yes, sir. Now Babu, I want to see something. Sir, what do you want to see? I want to see ki can I expand this sine square in terms of cos 2 theta? हाँ सर कुछ ऐसा था ना ट्रिगोनोमेट्री में एक्सप्रेशन sin square theta equal to 1 minus cos 2 theta by 2. Did you have something like this, guys, in trigonometry? Is there a branch of mathematics called trigonometry? Class 11 में probably है this particular topic. And जहाँ sin cos theta को हम ऐसे expand करते हैं क्या 1 minus cos 2 theta by 2 करते हैं दोस्त. तो if I make use of this to expand, अच्छा এটা মনে হয় phi নিয়েছিলাম নাকি রে? Everyone, did I take this theta or phi? I just want to maintain the same expression. Theta নিয়েছিলাম or phi নিয়েছিলাম? Anyone? Anyone just check the copy and tell me x equal to a sin omega t plus theta or phi আমি কি নিয়ে সলভ করছিলাম? Anyone just confirm me, just check the active phi নিয়েছিলাম তো let's take phi only. আমি দুটো ডিফারেন্ট নেব না. It doesn't matter but फिर भी. Babu, I want to expand this as a function of cos 2 theta. What I'll be getting? Half m omega square a square sine square of something is nothing but 1 minus cos of multiply the argument by 2 whole divided by 2. Yes or no? So u coming out to be equal to 1 by 4 m omega square a square minus 1 by 4 m omega square a square cos of 2 omega t plus 2 phi. Yes or no? Yes, sir. But sir, what's your point? Babu, can you observe that u is written, the potential energy is written as a sum of two terms? Yes, sir. Is one of the terms constant? Huh, sir, one of the terms is constant. This is a constant term. Is the other term varying as a function of time? Yes, sir, the other term is varying as a function of time, sir. Is this varying periodically with respect to time? Yes, sir. How did you know it's varying periodically? Sir, cos of time, sir, or the power of t is 1, sir. So, sir, it's a, sir, the cosine function is a periodic function, sir. Acha, acha. This term is a periodic term. Yes. But did we just see just few minutes before कि whenever we add a constant term with a periodic term, the resultant will also come out to be a periodic term. Yes or no? लेकिन सर इधर तो एडिशन नहीं है, सब्ट्रैक्शन है. अरे स्टूपिड, माइनस को ऐसे सोच सकता है ना, प्लस और माइनस. तो दिस इज आल्सो पीरियोडिक टर्म. Guys, what is the time period? First of all, what is the angular frequency of variation of this term? What is the angular frequency of variation of this term? Sir, you said whatever is the coefficient of t, that is the angular frequency. So what is the angular frequency? 2 omega. So what is the angular frequency of variation of this term as well? Same 2 omega. What is the time period of variation of this term? Sir, 2 pi by angular frequency. And what is the angular frequency? 2 omega. The time period of variation is pi by omega. So what is the time period of variation of this term? Same pi by omega. Sir, what is your point? Babu, just few minutes before we made an observation. Sir, what observation? Did we make this observation just few minutes before for displacement from main position, velocity, acceleration and kinetic energy? Did we make a table, guys, just few minutes before? एक कॉलम में, इफ आई एम नॉट रॉन्ग, था एंगुलर फ्रीक्वेंसी, एक में प्रोबेबली था टाइम पीरियड और एक में प्रोबेबली था फ्रीक्वेंसी. अच्छा, डिड वी सी दिस जस्ट फ्यू मिनट्स बिफोर कि डिस्प्लेसमेंट, वेलोसिटी और एक्सीलरेशन के लिए एंगुलर फ्रीक्वेंसी वाज ओमेगा. वो काइनेटिक एनर्जी में के लिए एंगुलर फ्रीक्वेंसी ऑफ वेरिएशन क्या था? वाज द एंगुलर फ्रीक्वेंसी ऑफ वेरिएशन ऑफ काइनेटिक एनर्जी वाज 2 ओमेगा. यस सर. एंड व्हाट अबाउट पोटेंशियल एनर्जी? सर 2 ओमेगा सर. यस. What was the time period for the first three? Sir, 2 pi by angular frequency. For the last two, 2 pi by 2 omega, that is pi by omega. Frequency क्या reciprocal of time period होता है क्या? कुछ ऐसा था क्या? Frequency is reciprocal of time period. Sorry. So Babu, can I make the final comment? Kinetic energy and potential energy in SHM are varying at a rate double that of the rate of variation of displacement, velocity and acceleration. डिस्प्लेसमेंट, वेलोसिटी एंड एक्सीलरेशन जिस रेट से वेरी हो रहा है, काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी आर वेरिंग एट अ रेट डबल ऑफ दैट. ठीक है. व्हाट इज द फिजिकल मीनिंग ऑफ दिस? जिस टाइम में डिस्प्लेसमेंट, वेलोसिटी, एक्सीलरेशन एक साइकिल ऑफ वेरिएशन फिनिश करेगा, विद इन द सेम टाइम काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी विल बी कंप्लीटिंग two complete cycles of variation. Yes or no? So can we remember this result, guys, from now? Ki if there is a particle performing linear SHM, kinetic energy and potential energy varies at a frequency, varies at a rate double that of the frequency of variation of displacement, velocity and acceleration. Can we make this comment? Yes or no? Anyone confirm me once? Is it clear, guys? Have you been able to understand? Can you make this comment? Anyone please confirm me. বলতে পারি কি? আমি কি connected আছি? Hello? Anyone confirm me? Am I audible? Is the voice coming?
Yes, sir.
Let's solve a problem. A particle oscillates, cakewalk problem, along the x-axis according to x of t equal to x naught times of sine square t by 2, where x naught is given as 1 meter. Babu, I want to know how the kinetic energy is varying as a function of x. There are 4 options given. You will be telling me which one is the right option. Option number A is given like this. কি বললাম বুঝেছিস? I want to know how the kinetic energy is varying as a function of x. Option A is given something like, yeah, একটু hold করো. Option A is given something like this. Acha, tell me, is this a variation of kinetic energy as a function of x? Let's check one option at a time. Just tell me, is it right or wrong? Is this a variation of kinetic energy as a function of x? As a function of x চেয়েছে, kinetic energy as a function of x চেয়েছে. Is this the variation of kinetic energy as a function of x? Yes or no? Anyone? Quick. Jaldi. Is this a variation of kinetic energy as a function of x?
No.
Anyone else? Is this a variation of kinetic energy as a function of x? Anyone? I have given you how the displacement is varying with time, and I am asking how the kinetic energy is varying as a function of x. So I simple ask korchi, is this the variation of kinetic energy as a function of x? Yes or no? First of all, তোকে যদি আমি ask করি, is the particle performing SHM or not? What will be your answer? Is the particle performing SHM? Anyone? Is the particle performing SHM? Is this following the general equation of SHM? Anyone confirm me? Is this following the general equation of SHM? Was this the general equation, guys? X equal to ও তো था a naught sin omega t plus phi. এটা তো sin square for कुछ दिया है. So no. ठीक. How will I solve this? Quick. जल्दी. Acha, tell me something. Just looking at this problem, if I ask you, oscillation is happening between which two values of x? What will be your answer? Oscillation कौन दो x के वैल्यू के बीच हो रहा है? साइन स्क्वायर का मिनिमम वैल्यू क्या होता है? 0. साइन स्क्वायर का मैक्सिमम वैल्यू क्या होता है? 1. तो कैन आई से गाइस द ऑसिलेशन इज हैपनिंग बिटवीन 0 to x naught. And what is x naught? 1. So can I make this comment? Just looking at the equation, can I make this comment that the particle is performing oscillation between x equal to 0 and x equal to 1? Yes or no? Does it make sense up to this? Yes. Are I good, sir? Anyone? Confirm me once. বলতে পারি কি এটা যে পার্টিকেল ইজ অসিলেটিং বিটুইন x ইকুয়াল টু 0 and x ইকুয়াল টু 1? দিস মাচ বলতে পারি. ডিফারেনশিয়েট দিস অ্যাজ আ ফাংশন অফ টাইম. আচ্ছা, তার আগে বল, সাইন স্কোয়ার এখানে দেখতে পাচ্ছি. ক্যান আই রাইট দিস ইন টার্মস অফ cos 2 থিটা? ডিসপ্লেসমেন্ট ইকুয়াল টু x নট, সাইন স্কোয়ার থিটাকে কি লিখি আমরা? 1 माइनस cos ऑफ 2 टाइम्स ऑफ दिस बाय 2. सिंप्लीफाई करेंगे तो क्या आएगा? x नॉट बाय 2 minus x naught by 2 into cos t. Ladies and gentlemen, is this a variation of displacement as a function of time? Can I write it like this? Will there be anything wrong if I write it like this? Yes or no? ঠিক লিখেছি তো নাকি? বল. Can I write it like this? Ajay, anyone, if I ask you, if this is an SHM or not, what will be your answer? Is this also an SHM, just the mean position is shifted somewhere else? Can I say, will it be justified if I say that, sir, this is also an SHM, just the mean position is shifted somewhere else, or it is not an SHM? This is homework till your next session. There are two options. This is not an SHM, or option 2 is this is an SHM but the main position is shifted somewhere else. एक तो आप आंसर हो सकता है कि this is not an SHM, oscillation but not an SHM, और second आप बोल सकते हो कि this is an SHM but the main position is shifted somewhere else. I'll be very happy if someone can explain. But anyway, Babu, I want to get how kinetic energy is varying as a function of x. I need this information. How will I get this? How kinetic energy is varying as a function of x? Quick. I can see there is something related to kinetic energy. इसको differentiate करेंगे with respect to time तो क्या मिल जाएगा? Velocity मिल जाएगा क्या? Differentiate करोगे तो क्या आएगा? x naught by 2 into sin t. Have I done it right? लेकिन this equation is giving me how velocity is varying as a function of time. I need how kinetic energy is varying as a function of x. How will I get this? अब बोलोगे simple. कैसे? अब बोलोगे सर kinetic energy क्या होता है? हाफ m v स्क्वायर. v स्क्वायर क्या क्या होता है? इसको स्क्वायर कर दो x नॉट बाई 2 इंटू साइन स्क्वायर t। लेकिन आप बोलोगे सर मुझे आई डोंट नीड द फंक्शन ऑफ टाइम, आई नीड इन टर्म्स ऑफ x। अरे ठीक है, तो लेट्स राइट इट इन टर्म्स ऑफ x। लेकिन कैसे? वो कैन आई सब्स्टिट्यूट फ्रॉम हियर? कैन आई सब्स्टिट्यूट द एक्सप्रेशन ऑफ sin square t फ्रॉम हियर and can I get this as a function of x? Yes or no? Can I get it from here? m omega square by 4 sin square t को क्या हम लिख सकते हैं क्या 1 minus cos square t? Can I write it 1 minus cos square t? Anyone? Babu, from this expression, can anyone confirm me? Twice x by x naught is coming out to be 1 minus of cos t from this expression. So what is the expression of cos t? Is cos t coming out to be 1 minus 2x by x naught? So in place of sin square t, it is 1 minus cos square t. And what is cos square t? 1 minus twice of x by x naught का whole square. Yes or no?
सर m/2 x square हो जाता है,
और एक बार बोल,
m/2 x square हो जाता है।
বাকি সব টার্ম মানে ক্যান্সেল হয়ে গেল, এখানে একটা লিনিয়ার এক্স থাকবে। तो वो काइनेटिक एनर्जी इज कमिंग एज m ओमेगा स्क्वायर बाय 4, थोड़ा सा सिंपलीफाई कर 1 माइनस a স্কয়ার মাইনাস 2ab, এই ক্যালকুলেশন চেক করে নিবি, প্লাস x স্কয়ার আসছে, এটা 1 1 ক্যান্সেলড, সিম্পলিফাই করলে কি হবে m ওমেগা স্কয়ার বাই 4, সরি ওমেগা স্কয়ার বাই 4 ইনটু 4x বাই x নট মাইনাস 4x স্কয়ার বাই x নট স্কয়ার। ঠিক লিখেছি গাইস? ইজ দ্য এক্সপ্রেশন কামিং সামথিং, সরি এটা x ছিল না, সরি মাই মিস্টেক। Is the expression coming something like this? Yes or no? Is the expression coming something like this? Yes or no? Anyone? Expression কি এটা এটাই আসছে তো নাকি? But guys, whose equation is this by the way? এটা কার equation? Is this also a parabola? আমি আরেকবার লিখছি। Kinetic energy is given as m omega square by 4 into 4x by x naught minus 4x square by x naught square. Whose equation is this? You are plotting kinetic energy along y-axis. Kinetic energy is given as a quadratic function of x, or x square का coefficient is negative. Is it supposed to be a downward parabola? Kinetic energy is a quadratic function of x and the coefficient of x square is negative. It has to be a downward parabola. Was this a downward parabola? No. So this is not the option. Clear? ठीक है? Option B था something like this. Is this parabola? No sir, it's not a parabola. Is it parabola guys? No sir, it's not a parabola. This is also not the option. Option C tha something like this. Is this parabola? No sir. Option D tha something like this. Is this parabola? Yes sir. Downward opening? Yes sir. So is this supposed to be the answer? Sir, the other three are not the option. So sir, this has to be the right option anyway. Is it clear? Achha sir, can you prove this? You were saying कि at x equal to half kinetic energy will be maximum. Sir, can you prove this? Cakewalk. But kinetic energy is given as a function of x. ठीक है? Kinetic energy maximum कब होगा? When this quantity will be maximum. Can I assume it as a function of x, guys? Can I assume it as a function of x? But whenever a differentiable function, chalo, let's not use the term differentiable. Whenever a function achieves maximum or minimum value, डेरिवेटिव इन टर्म्स ऑफ x जीरो होता है क्या? हाँ सर। तो डिफरेंशिएटेड इन टर्म्स ऑफ x क्या आएगा? 4 by x naught minus 8x by x naught square. ये ठीक लिखे जी 8x by x naught square, it will be equal to 0. Anyone, have I written it right? Please anyone confirm me once. এটাকে x naught দিয়ে মাল্টিপ্লাই কর বোথ সাইডে, একটা 4 দিয়ে ডিভাইড কর, so I will get 1 minus 2x by x naught. Have I written it right? Equal to 0. So 1 is coming out to be 2x by x naught. একবার একটু চেক করে আমাকে বল, তাহলে x equal to কত আসছে? x naught by 2. In the question, was it given x naught equal to 1? Yes sir. So at which value of x you are going to get the maxima? Half only. So see, at x equal to half only, it is given the maxima. Clear? ठीक है? Sir, was it supposed to be this much lengthy? No sir. It could have been just in few lines, but I just wanted to have a full discussion of this problem. Matlab, I could have simply explained by looking at the options only which one is right and which one is wrong. But there would be at least one student in class who will be wishing to get the expression of kinetic energy as a function of x, who wants to go by this general approach कि पहले kinetic energy as a function of x, then from that let us try to understand how kinetic energy is varying as a function of x. So for that student only I make this total discussion. But just looking at the options only, this could have been marked. Okay? This question came in JEE Mains 2025. Okay? Any doubt? By this we finish the kinematics of SHM. I am not studying the numericals of the kinematics of SHM today only because some of you have done this chapter for the first time with me. So if I do the numericals today only, it will be like I'll be solving and some of you will be just listening. So it will be better ki before the Friday session, make a proper revision after this. Friday, first 1.5 hour will be solving the numericals of the kinematics of SHM. And then we will jump into the more important part, which is the dynamics of SHM. Okay? So by this, we finish the kinematics of SHM. So Friday, as usual time, the normal class time, first 1.5 hour will be solving all the possible variations of numericals up to this part of the kinematics of SHM, and then we'll jump to which part? The dynamics of SHM. Okay? Thank you guys. You can leave.